The decorator pattern is a commonly used structural pattern from the well-known Gang of Four design patterns. The intent of the pattern is to attach additional responsibilities to an object dynamically. A decorator thus provides a flexible alternative to subclassing for extending functionality. Just like the adapter pattern, this pattern is sometimes called a wrapper. Attaching additional responsibility or behavior to a class can easily be done by simply adding an additional method to the class. In this case, however, we need a way to attach additional responsibility to an object and not to a class. We want to allow this dynamically, so at runtime. That's a bit more complicated, but not that much really. The fact that this pattern is sometimes called a wrapper should already give you a good idea of how something like this can be implemented. Let's clarify this with a real-life example. In one of my other courses, I use a cloud mail service and a regular on-premise mail service to send mail. Both of these implement a simple iMail service interface, which exposes one method, send mail. Now imagine I want to add some functionality to this service. Say that I want to start collecting some statistics. For example, how long does it take sending a mail? Or how often is the send mail method accessed? I could add that functionality to the different mail service implementations, but that violates the single responsibility principle for that class. Moreover, imagine that I want to add even more responsibilities, like logging when a mail is being sent or storing all the sent mail messages in a database somewhere. Our classes would get littered with code that doesn't belong there. And that's where the decorator pattern comes in. Let's start with our iMail service and both implementing classes. We're going to create a wrapper around our iMail service to add the functionality we need by overriding the sendMail method in that wrapper. We can call that wrapper mail service decorator base, for example. It's an abstract base class, which also implements the iMail service interface, thus exposing a sendMail method. Next to that, we also store the iMail service instance we want to decorate in this decorator. It's now up to concrete implementations of the decorator to effectively add functionality. We could have a statistics decorator that derives from mail service decorator base, calculates some statistics and then calls into the sendMail method. We could have a message database decorator which stores all the messages that are being sent in a database, and so on. Instead of directly calling, for example, cloudmailservice.sendmail, we can now call statisticsdecorator.sendmail or messagedatabasedecorator.sendmail. So with a few simple interventions, we can easily extend the functionality of the mail service objects without having to resort to an explosion of subclasses or large inheritance trees, and while at the same time sticking to the single responsibility principle. That's pretty cool, right? From this real-world example, we can now extract the structure of this pattern.